The Oakridge Reservation holds an important place in our nation's history, and it continues to be a vital part of our national security and scientific research community. But parts of the reservation require cleanup as a result of decades of energy research. The U.S. Department of Energy looks to the Oakridge Site-Specific Advisory Board as the voice of the community on environmental issues. You're welcome to attend meetings of the Oakridge Site-Specific Advisory Board to learn more. Call us or visit our website.
All right, tonight our presentation is going to be on DOE's technology development to support Mercury cleanup strategy. And our presenter is Mr. Mark Peterson.
It's a pleasure to be here and a pleasure really to talk about Mercury technology development in East Fork Poplar Creek. It's a favorite topic of mine lately, and it's a real pleasure. And I appreciate all the folks who have come to hear about this on a nice day out to come in and listen to a technical talk. That's really great. So thanks for coming. Before I get started, I want to just thank all the folks that are engaged in this program. I say this a lot because it's true. I'm very much a messenger. This is really a team approach from managers to engineers to scientists to technicians, a number of folks who are involved in this program and helping it be successful. So thank you to all those folks. So a little bit of introduction of what I want to talk about. I'll just give you a little bit of background about what we do at the Aquatics Lab at ORNL. And then get right to the main topic and talk about Mercury and East Fork Poplar Creek, and specifically on the technology development program that we've started here recently. And as part of that discussion of the technology development, I really want to take quite a bit of my time to talk about the strategy. A lot of effort went into the approach that we took, and I think it's a good one, and I want to kind of lead folks through that a little bit, but then also get to some of the key findings. We started this project back in August of 2014, so it's been about a year and a half, so we have some results I can share with you tonight. Okay, so I apologize, it's a little hard to see here, but just to highlight that aquatics research, it may be surprising to some of you, goes really back to the very beginning of the shortly after the Manhattan Project. There were researchers out looking at radioactivity in the nearby streams. Then let's see here, get this working. Let me try something else here. And then in the 1950s, there was actually a field research station built on the Clinch River to evaluate various contaminants in the reservoir. And then it was in the 1960s, the Walker Branch watershed started, a very famous watershed, 50 years of research going on. The NEON group, ORNL, been involved there. The Aquatic Ecology Laboratory was built in the 1970s, and I'm glad to hear that there'll be some folks coming out to the lab next week to get a tour of the facility. And then in the 1980s, the Biological Monitoring Abatement program started. Some of you may be familiar with that program. 30 years of assessment of various streams, including East Fork Poplar Creek, and of course, evaluating the mercury issues there. So the bottom line, a very rich history of aquatics work, and especially focus on the local environment and trying to improve it. So today, the lab is really one of the premier aquatics facilities. It's one of a few in the Southeast. We're again focused on solutions to the U.S.'s most challenging energy and environmental related problems. It's a large facility with a number of people working in it, and we're very closely tied to a number of the various organizations here locally. trying to improve the environment. Okay, so you've got a little bit of background on why we're interested in mercury. Of course, we have a mercury issue here in Oakridge, and that really started primarily back in the 1950s when there were large quantities of mercury that were released from Y12 into East Fork Poplar Creek. It was in the early 90s that there were some major CERCLA actions, so various RIs, feasibility studies, a record decision issued, and that remedy focused on the floodplain, and that's really important to understand. It was not focused on the boundary within the creek. It's not focused on the stream itself, but focused on the floodplain. And as part of that investigation, a lot of mercury was removed from the floodplain in East Fork, around East Fork. And then since that time, relative to the East Fork environment, most of the various actions, remedial actions, abatement actions, have focused on within the Y12 plant, which of course is at the headwaters of East Fork. And then it was in 2013-14 timeframe that there was a number of workshops, a number of interactions with regulators and other stakeholders where it became apparent that a strategy was needed that not only included the remediation activities at Y12, but considered the downstream environment, that the downstream environment, that historical contamination was a continuing source, continuing issue in the environment that we needed to look at. And I think another key outcome of that strategic planning was a feeling that technology development, the latest science, was needed to be applied to this very complex problem. And so currently and in the future, the big activities, in my view, for East Fork Poplar Creek and Mercury is, of course, the design and construction of the mercury treatment facility. It's addressing the largest discharges of mercury from the Y12 facility, and also the technology development program, which I'm going to talk more about. Okay, so this is just a general timeline for how these various mercury activities or remedial activities and studies are planned. So the mercury treatment facility, is going to be, are you getting feedback there? My fault? Okay. There's, of course, design and construction over the next few years, and then concurrent with that activity, the Mercury Remediation Technology Development Program. I mentioned it started in August of 14, so we've been at it for a year and a half. But ultimately, we're hoping that these activities will lead to an analysis of alternatives for East Fork Poplar Creek in the next decade or so. So when we were asked to look at how we would develop a mercury technology development strategy, of course it was important to be consistent with the priorities and timeline of the various remedial activities. It makes sense that we're focusing on Y12. It's at the headwaters, and so any kind of cleanup or remediation would really need to follow timeline-wise after those activities or major activities at Y12 are being done. The strategy recognizes that it's a watershed problem. It's not a very discrete source kind of issue, that the watershed is a complex place. There's a lot of different moving parts there. We did an extensive literature review, evaluate a lot of on-site data, and our big goal for technology development, again, is to try to find solutions to remediate potentially lower East Fork that is preserving or enhancing of the natural resources there. Conventional approaches to mercury or to any kind of cleanup action in soils or sediments are very intrusive to remove soils from the environment. And so we want to look for solutions where we maybe don't have to do that but can still reduce risk. So our target ultimately is we want to reduce mercury flux, reduce mercury concentration in water to hit our ambient water quality criteria goals, and we want to try to reduce mercury concentrations in fish and ultimately take the signs down from East Fork Poplar Creek. That's our goal. So we adopted a technology readiness level approach, which is this is an approach defined by DOE for use of technology development across the DOE complex. And The approach really starts very broadly in doing paper reviews. We put out a sort of a white paper, which I've got some copies here for, that kind of highlights all of the various, highlights the approach that we're taking and why we're taking that approach. We're also doing more study site characterization early in the early years, and then over time, increasingly do field and laboratory batch or bucket scale testing, ultimately leading to some sort of pilot, recommended alternatives, and then an action. So this is sort of the overall paradigm that DOE recommends for how we develop technology development. So we're following that in how we're going forward in East Fork. Okay, so we have 3 major tasks in the Mercury Technology Development Program, and I'm going to take a little time here because I think it's really important. For many contaminants, it's all about source control, limiting contaminant release from storm drains or from a facility site or groundwater contamination. But mercury is very different. And USGS in a recent publication focused on mercury and surface waters across the U.S. focused on 3 key factors that determine the level of mercury contamination in fish. And this is actually the first sentence in that report, and it's done very well. 3 key factors: the amount of inorganic mercury available to an ecosystem. So that is the source, the amount of flux coming in. Another major factor is the conversion of that inorganic mercury to methyl mercury. Inorganic mercury is largely not toxic, and methyl mercury is the more toxic form. So the environment, the surface waters, the sediments, that environment that, the microbial communities in that environment that help convert that inorganic mercury to methyl mercury. And then the last factor is the bioaccumulation within the food chain. And so you really need to have source, mercury methylation processes, and the food chain. All of these interact to force a system either into low levels in fish or high levels in fish. So as an example, out west, there are many sites that have have high mercury loading from gold mining, but then it goes into systems where the water chemistry is such that, and biology is such that you don't have problems in fish. Conversely, there are places where you have relatively low inorganic mercury in environment, say Ontario or places in Maine, where then you have, low pH, you have the dissolved organic matter, you have processes that encourage methylation, and then you have real old fish like lake trout and northern pike. And so in some cases, you can have low source, but you have the water chemistry and the food chain driving a problem in fish. So it's really that combination that helps, that contributes to what we see in fish. And so that's the approach that we've taken in the Mercury TD program, is to focus on, okay, well, what do we need to focus on in the East Fork environment relative to sources and controlling flux? And so that's primarily soil, particularly bank soils and groundwater. And then can we develop ideas for perhaps changing water chemistry to try to limit methylation or enhance demethylation? So we want to look at water chemistry and sediment manipulation. And then lastly, look at ecological manipulation. If we have a different kind of food chain, maybe we can help reduce risk. So that's the major approach that we use throughout in this program. Okay, so one of the things we want to do very early on is understand the system, so we can develop the best technological solutions. And I've used this analogy before. If you're going to clean up a contaminated building, you better understand that building really well before you can decide how you're going to remediate it, how you're going to develop technologies to clean it up. And it's the same way with the stream environment. We don't know what tools we may be able to apply until we really understand what's going on in the system. So initially, we've done a lot of focus on the banks and looking at mercury, soil erosion and mercury releases from those banks. We actually put a kayak into the water from the Outfall 200 at the head of East Fork Poplar Creek and floated it all the way down to the mouth with video cameras on the front and the sides, and examined erosion, foot to foot, all the way down the creek. And once we have erosion rates, then we can analyze the mercury in the banks and determine what kind of flux we're seeing throughout the bank. So we looked at evaluating mercury and soil erosion. We've added some gauging and water chemistry stations throughout the creek to get a better handle on the water chemistry. And then in the biota, we're focusing more on methylmercury. A lot of the work that's been done in East Fork to date has been focused on total mercury. Methylmercury is what we're concerned about from a human health standpoint. So we really wanted to get more information on the methylmercury dynamics. Okay, so let me share with you some of the key results. First off, some of the soil and groundwater source control task. An evaluation of stream banks. I mentioned the kayak surveys. This top figure is showing the amount of flux measured as kilograms per year per 100 meters along East Fork Poplar Creek. So here's Y12, here's the headwaters of East Fork Poplar Creek, and then it moves downstream towards the mouth. And as you can see, the highest concentrations of flux from the banks is in that upper section, extending from about EFK 16 to 22 in that area. Total estimated amount of mercury from the banks is about 38 kilograms per year, which is pretty significant. And as part of these surveys, we discovered that there was a historical release deposit where we really had some higher concentrations than other areas within the banks, and I'll talk more about that. So it's a little bit more detail. This is some work where we looked at mercury concentrations from the top of the bank to the stream at 4 locations. And then within each of those horizontal plugs going into the bank, we measured mercury at various depths within that core. And this is pretty interesting. So if you look at the top of the bank, we're seeing mercury concentrations in the 60 parts per million to maybe as high as 120. You move a little bit of distance further down, and we're getting concentrations about 10-fold higher. And that's related to that historical release deposit. Interestingly, in both of these, for the most part, pretty similar concentrations at the surface of the bank, and then also vertically in, or horizontally into the bank. But then you get down into this core, and we've got concentrations in the 200 to 300 parts per million range right at the surface, and then they drop off, and they're not there further into the core. And then at the other site, or the other location in the bank, we've got very little at the surface, and then it increases with. So what this is telling us is you got a lot of variation out there, and it's very dependent on the history of when mercury was released and how it was deposited. But a key thing for technology development is that maybe these levels in the 20 parts per million are not a big focus. Maybe we don't need to clean up all of that bank. Maybe what we need to focus on are these higher concentrations that are making the most difference relative to flux overall in the watershed. So we've been doing a lot of that kind of characterization effort to really focus on where are the primary target areas for potential technology development where you make a difference in decreasing flux. In the water chemistry task, the focus has been on 4 major sort of subtasks. One, trying to prevent methylation, looking at options that might promote demethylation. Remember, microbes methylate, and they can also demethylate. We're also looking at solid aqueous partitioning. If you can keep mercury in the bank or in the soils and sediments and not into the water, that's a good thing. So we're looking at sorbents and other kinds of solutions to try to encourage binding in the environment. And then lastly, we're looking at actions within Y12 where we can maybe look at potential alterations in chemical use at the facility that might help with mercury release. So I mentioned that we've got some water chemistry sampling that is done upstream, middle, and downstream East Fork. And I know it's a little complicated graph, but let me kind of walk through this. These different colors are just showing different seasons. So we've got orange, autumn, blue, winter, green is spring, and red is in the summer. And this is showing rates of total mercury, of methyl mercury. And what's obvious when you look at this seasonal pattern is that if you look at these concentrations, you have higher methyl mercury in the spring and summer. This is what you'd expect. It's when the microbial community is active, warmer temperatures. That's when you're seeing the highest methylation in the creek. And then the solid bars versus the open bars are just highlighting the area in upper East Fork is in solid, and then the open bars are in lower East Fork. And so what's clear is that you get much higher methyl mercury in the lower part of the creek than in the upper part of the creek. And so that line is just showing the ratio there. So around 2 to 4 times higher methyl mercury in the lower part of the creek. And so, why that is under investigation. We don't know why that is that methyl mercury is higher in the creek. One of the things we've been looking at is the sediment characteristics. This is some work that Scott Brooks did looking at using sequential extraction analysis to kind of evaluate the binding properties or of the soil and sediment. And so what this sequential extraction does is that it uses increasingly more aggressive solutions to see how much mercury can come off of the soil or sediment. So an F1, that's just deionized water, anaerobic deionized water. So if you get a lot of mercury coming off in F1, then basically that mercury is highly available to go into the stream and be mobilized. In contrast, F5, you can make the analogy of the tornado kind of thing. F1 is very, very little or very less aggressive, and F5 is the most aggressive chemical treatments to be able to pull. So if it's F5, it's largely bound to the soil and sediment, and it takes aggressive chemical treatment to remove it. And so some key points here. The good news is 97% of the mercury extracted is in those F3 to F5 fractions, which is really good news. That means most of that mercury is going to be very hard to come off. So it's going to be bound to the soils and sediments, in this case, the sediment analysis. The maybe not so good news is that as you move from upstream East Fork to downstream, you see that green line. You get increases in the F3 fraction, which Bloom, who developed this procedure, most closely correlates with methylation potential. So, we're seeing higher methyl mercury in the lower part of the creek, and kind of makes sense that we're seeing the chemistry is sort of suggesting that there is something going on why that methylation is happening. So this is just some things we're trying to investigate to get a better handle on the methyl mercury in the lower part of the creek. And then the last task is the evaluation of the use of ecological manipulation or changes in bioaccumulation. And this graph is just highlighting that, or figure is highlighting that, food chain makes a big difference with mercury. The risk for mercury is not touching the water. It's not drinking the water. The risk is fish. And so food chain drives how much mercury is biomagnified and how it accumulates in the environment. Longer food chains enhance mercury bioaccumulation. And each organism has different bioaccumulation potential depending on what it's eating. And interestingly, the greatest biomagnification step is the step between water and algae. Remember, water concentrations of mercury are in parts per trillion levels. And that biggest jump is in the 100,000 to 1 million range jump between what's in water and what's in algae. So if you can control algae, you might be able to change the overall uptake of mercury in the food chain, or perhaps change invertebrates or fish populations, et cetera. So that's what we're investigating, is can we change pathways of exposure? And so just the fish population can make a difference. And we do fish management activities all the time. We manage reservoirs for different kinds of fish. We control fish populations. And in Lower East Fork, we have 3 species of sunfish, and they accumulate very differently. Bluegill largely eat terrestrial insects, and so they have very relatively low levels of mercury. Redbreast, which is at that light green, they're omnivorous, so they eat a combination of invertebrates and fish, and they accumulate a little higher. And then rock bass, which largely eat fish, accumulate almost twice what you see in bluegill. So one of the solutions might be, overstock in bluegill. Create a population of bluegill in the creek, and you've halved the amount of mercury risk in the system. So those are the kinds of things that we're looking at. And similarly, in invertebrates, the percent methylmercury varies significantly by species. And so I've just highlighted 2 species that are common prey for fish, caddis fly and crayfish. They're actually fairly comparable in the total mercury, but caddis fly have very little methylmercury, the toxic form, while crayfish have very high methylmercury. And so, if we can do some tweaks to the environment to be able to emphasize lower methylmercury invertebrates, maybe we can change the ultimate concentrations in the fish. And then, of course, so we've been doing all these various characterization studies, and then we've been increasingly looking at how we can develop the technologies, the mercury control technologies that might make a difference. We've been working with our colleagues in the carbon fiber arena at ORNL. We're developing some lignin-based carbon fibers, and we've been looking at some other kind of sorbent mats that might be applied. Those mats could be applied onto the bank and then try to and help prevent loss of mercury from the banks into the water. We've been looking at water chemistry and sediment manipulation ideas, working with the Y12 folks and folks to see if we can maybe tweak some of the chemistry there. And I'll mention too, one of the areas that we've been really kind of excited about is the idea of perhaps introducing native mussels into East Fork. They were there historically. They were extirpated during the years of most impact to East Fork. And mussels make a big difference in water in water chemistry. I mean, if you look at this is with no mussels and this is with mussels, you can see that cloudy water, mercury binds to particles. So a lot of that mercury that's in solution that may go into fish concentrations, if it goes into mussels, it could be a good thing. And because one of the things that's also really interesting about mussels is that they accumulate very little methylmercury. They're almost totally inorganic mercury, which means that that's not a viable pathway for risk. So we're looking at sort of the overall mass balance within the biological community, and if we can push some of that mercury that's in the fish population maybe into mussel population, might be a good thing. And TWA is very excited about this. They've got a new facility in Nashville where they're trying to restore native mussels into streams across Tennessee. And so I think there's a real possibility there to not only reduce risk, but enhance the natural resources in Oakridge. So I think there's a lot of exciting things going on there. One of the proposed things that we're hoping to do is to build a near creek research facility, which would be highly desirable to be able to bring East Fork Poplar Creek water into tanks and chambers to be able to do some of these experiments and better evaluate the technologies that we might apply. Examples include sorbents and columns, be able to manipulate water sediment chemistry or make the biological changes. It's hard to do to manipulate the stream itself initially without a large investment. If you can bring water into tanks and do that on a smaller scale, it's a nice bridge between the field and the bench scale type of work that we do in the laboratory and the more pilot scale kinds of evaluations. So, and again, trying to develop environmentally friendly solutions with that facility. And so I'll just end to say that I'm excited about the work that's going on in Oakridge relative to Mercury, and in general about East Fork Poplar Creek. We've shown through the BMAP program some substantial improvements in water quality in the creek. That's really good news. Some of you may have heard Ornell. It's certainly not in my group. Scott and others were involved in a major breakthrough in identifying the gene that methylates mercury. It's published in Science magazine, and they've been evaluating all of the different kinds of microbes that methylate mercury. So, I mean, these are mysteries for the last 40 years, 50 years that have just been recently identified that could have application in the future. We've done some work on water chemistry at the Savannah River plant, and some of those activities have worked. We've recently published a paper that where we saw fish concentrations go below the 0.3 target. The ecological manipulation has been applied in Oakridge at the P1 pond at K25, and risk has gone down. We've hit our regulatory targets, and we've enhanced the natural resource value. I think most stakeholders feel like that has been a good success story. And then lastly, you know, the city of Oakridge with the water storage tanks, that's going to help water quality. It's going to help with the limiting storm flow, which helps with at higher storms, or you get more loss of bank soils. That's going to help things. And of course, the Y12 mercury treatment facility is really good news. So just overall, I'm just feeling very excited and feel like we're really going to be able to have a chance to make a real difference in the environment.
So we will move into the presentation portion of the evening, which will be a state of the Oakridge Environmental Management Program. And Dennis, would you like to give us an introduction, please?
Yes. Jay Mullis is the Deputy Manager for the Department of Energy's Oakridge Office of Environmental Management. In his role, he assists in directing and overseeing the environmental cleanup of the Oakridge Reservation. This includes the former K25 gaseous diffusion plant, the Oakridge National Lab, and the Y12 National Security Complex. Jay was promoted to his current position in February of 2015. Previously, Jay was Director of Engineering, Safety, and Quality Division for the Oakridge Office of Environmental Management. In his capacity, he was responsible for OREM's engineering, nuclear safety, industrial safety, quality, and waste management program. Jay also served as the director of OREM's project management division and led the source evaluation board that resulted in the award of UCOR contract. As you know, they are the primary contractor on the reservation. Jay holds a bachelor's degree in electrical engineering from the Citadel, a college in South Carolina. He is licensed professional engineer in the state of South Carolina. He completed extensive reactor operations training and qualifications while working for the Navy in Charleston Naval Shipyard, and he has been fully certified facility representative for DOE. Jay has more than 25 years of federal service. His experience consists of approximately 9 years working at the Naval Nuclear Propulsion Program at the Charleston Naval Shipyard, with a balance of his service working for DOE in various assignments that include environmental restoration, decontamination, decommissioning, nuclear safety, and waste management activities. With that background, looking forward to Jay's presentation this evening on the state of the Oakridge Environmental Management Program.
Some of the changes here that we've had, if you've never been briefed on this, one of the challenges, and I'm just going to walk up here instead of trying to figure out how the laser pointer works, if it has a laser pointer, was to get the project management and the project controls folks together in the same division. So there was a lot of crosstalk on our projects because there seemed to be some gaps whenever we had them in different divisions. So that was one of the reasons for the reorg we had. We added, of course, the contracts group which we used to get from the service center, the old ORO. We moved those in-house so that all our contracts now we can administer in-house and not have to go to science. And of course, we combined the facility representatives and the safety SMEs along with the engineering group so that everybody that had both field experience and field oversight responsibilities and the subject matter experts that support them, industrial hygiene, health physics, et cetera, and the nuclear safety and engineering folks were all in the same division. And part of that was to carve out the quality group so that they were a separate entity. They used to be about 5 years ago, and we had a reorg right before Mark Whitney got here and included them within the engineering organization, and they felt like they were buried down within the engineering organization and did not have access to senior management and did not have themselves as a single QA entity, but were kind of lost within the engineering organization. So part of that was to carve them out. What's not shown on here is I meet with them on a periodic basis, so they have direct access to the front office, as it were. And then, of course, we had the program support group and the business services, this is where our regulatory affairs sits, SSAB administration, and over here are the fun things like IT, travel, training budget, et cetera. And so Dave, one of the changes is Dave, with Ed Worth's retirement, I don't know if y'all knew Ed, but he retired about a month and a half ago, and we recently promoted Dave to that position. So, and if you guys have any questions, feel free to ask as we go through. We don't have to wait to the end unless that's convention. Talked about this a little bit earlier. A few years ago, Sue and Mark came up with a set of very clear expectations or goals to kind of define our plan in 4-year implementation periods. The first was Vision 2016, which was to get all the GDP plants down. We achieved that at the end of August 30, with the big celebration out there. Pretty amazing achievement. I came here in the mid-90s. Actually did not go into the federal building, went out to what was then called the K-25 site office, which was on site out there in a building that doesn't exist anymore, in K-1001, in fact. And I got out there, there were a lot of people on site. There was not a lot of work going on. There was a lot of S&M. Was that me causing that? Probably too close to that. A lot of S&M going on site, but really all that was going on out there was the Tosca incinerator. Move away from that. The Tosca incinerator, a few dirt cleanup projects. Okay. A few dirt cleanup projects. There were some cylinder projects out there, not the large cylinders, but just gas cylinders, and that was about it. So for me personally, it's been kind of amazing to see the transformation. This, of course, was the old portal. You used to have to go through that every day to access the site. Not so much anymore. So very different out there. Vision 2020 is to finish up ETTP and get that completed, which gives us the opportunity by 2024 to start the work in earnest over at Y12 with the Mercury cleanup. I'm not going to go into detail here. This is kind of amazing to me. Believe it or not, the 4.5 million square feet demolished isn't really amazing to me, I guess because I've been through all those buildings. It's the number of truckloads that was shipped and didn't get anybody hurt. So whoever came up, and I think this board had something to do with it, I think Steve McCracken did as well, with the haul road was a genius. Because that has kept us out of commerce for many of those shipments and has, I think, resulted in much better and safer operations. In fact, UPF uses part of the haul road now over at Y12, and there's interest as well with some of the science missions coming online to use portions of the haul road as well. So that actually has been a very big benefit to us, and I think earlier versions of the board, that was one of the board's recommendations. The other one was just kind of amazing to me is the miles of piping. I've been in the buildings, I got the square foot, but that many miles of piping, even though I've seen the piping, was just kind of amazing. So the numbers to me are kind of interesting. And of course, we've transferred quite a number of acres to private entities and non-DOE entities out of the site now. Here's the budget outlook for 17. It generally supports our program goals. You can see the president's budget. If you look down here at the bottom line, which is really where I'd like you to focus for a minute, we don't expect to get the president's budget. We expect to be somewhere between the House and the Senate mark. Either one of those lets us complete our priorities. Of course, the Senate mark's a lot better, but we suspect we'll be somewhere in between those two. I would point out that you find it here, historic preservation, the $6 million, that'll actually allow us not only to finish the History Center, but also to start on the equipment building. But without that, we still finish the design, we still finish the History Center. So if there's any questions on that? Okay. One of the things we want to do and we want to leverage is to all the experience that we've learned over the years at ETTP, and there's been a lot of hard lessons learned out there. Having worked here for a number of years in the ETTP program, I was out there for one of the early accidents where the gentleman died because of the fire when he was removing some of the converters in K33 to ship them up to Portsmouth and Paducah. I was out there when the gentleman fell through the floor. And so we've learned a lot of valuable lessons on how to D&D old, dilapidated buildings. We don't want to lose those lessons, so we want to take those lessons, the trained and experienced workforce we have, and transition them as smoothly as possible to continue the D&D efforts at Y12 and ORNL. Part of being able to do that over at Y12 are projects we need to start today. One of those is the Mercury treatment facility for Outfall 200. That'll be an important control measure for us when we go after the WEMA area, the West End Mercury area at Y12, which is where Beta 4, Alpha 5, Alpha 4 are located. We need to have this in place when we start disturbing buildings and soils because we think the mercury flux will go up, and this will be a good control measure for that mercury flux. The other thing we're going to need is a new on-site disposal facility. EMWMF will basically be full with waste from ETTP. There may be a little bit additional space, but by the mid-20s, when we're doing D&D in earnest over there, we'll need another disposal cell. We have increased focus. Y'all have probably heard about some of this in the news. It actually, I think, made the Wall Street Journal. I didn't ever think I'd be on a program that made the Wall Street Journal. My kids one time Googled me and said, "You don't come up a whole lot on Google, Dad. Doesn't that suck for you?" And I said, "No, the smaller footprint I have in digital space, the better off I feel." But of course, I remember when you did work without email. My kids can't believe you could actually do work without email. So, but we're focusing our attention on reducing the excess facilities now that exist over at Y12 and ORNL. Oakridge has some of the worst. That was the quote out of, I can't remember if it was the GAO report or the IG report, but we've had reports out of both saying you need to do something about the buildings. There's 350 of these facilities in Oakridge, which accounts for about 25% of DOE's inventory, and 46 are classified as high risk or the worst of the worst, and which accounts for 40% of DOE's inventory of the high risk facilities. So here you have the Beta 4 building, you have the biology complex, and we're actually starting work. We've started work in 16 on these buildings. That funding will continue on into 17 to continue to do risk reduction activities. We don't actually have enough funding to start D&D, but we're doing removal of hazardous material, sampling, completion of the appropriate CD documentation so that we can get through our project management requirements within the department to be able to move forward to eventually do the D&D. So we're removing some of the Colex equipment that are out there. So what we're trying to do is stabilize facilities so that they can go into long-term stewardship until we can D&D them, and over time reduce the risk, get rid of the source term that's in those buildings. NNSA, which owns some of these buildings, and of course Science owns the biology complex. NNSA also has money to start working on some of the buildings, and so we're working in concert with them. One of the things we did was take advantage of their roofing contractor to roof Alpha 4 while they're roofing Alpha 5 in the Beta complex. So there's a lot of cross-program synergy going on, which is a good thing. This will give you an idea of the magnitude of the problem, just to orient you a little bit. Now, this is the West End Mercury area here with the Beta 4, Alpha 5, Alpha 4 building. And so you're looking at the entrance to the plant down here, but all the red buildings are the excess facilities. Some of them are owned by EM, some of those are owned by NNSA, some by Science. Here's the biology building that's owned by Science, and there's actually an NE facility in here as well. So as you can see, that's spread throughout the Y12 complex. They would like to go from about an 800-acre operation to about a 100-acre operation, and essentially in the future be up in this area here with their new facilities. This is at Orinell. You can see we're kind of in the middle of the old downtown, and those are all the various facilities. To orient you, this is Graphite Reactor, which is part of the National Historic Park, Manhattan Park that's going on. Many of these facilities are already EM facilities. A lot of those are hot cell facilities and old reactors that were involved in various isotope production and research over there. You've got about 26 million curies and hold-up material in these facilities that need to be dealt with. Many of those transuranic and odd isotopes from all the isotope research. In addition to that, we have some other important programs that continue, treating and disposing of the true waste that's out there, direct disposition and processing of U-233. Direct disposition campaign is ongoing and going very well. Surveillance and maintenance of the facilities that we currently own, awaiting D&D. And what has become prominent here recently, the life extension programs and engineering evaluations that we're doing of some of the facilities that have to continue to operate at Orinell, such as LGWO. We actually had identified that we had some maintenance issues. Over the years, EM had reduced the maintenance budgets and focused on D&D, which has led to some problems out there. We actually recognized that, and we're starting to put money in that when the whip accident occurred. The whip accident actually complex-wide with the EM really put a spotlight on it. This is a picture of some of the LGWO piping that we found when we removed lagging. Yes, either one of them.
LGWO.
Oh, sorry. Liquid gaseous waste operations. That's that takes all the liquid and gaseous waste that's at Orinell and treats it. So about 50% of that comes from EM operations. About 50% of the waste right now comes from Orinell operations. So without that, facilities at Orinell would actually, production facilities and research facilities would shut down. But you can see that you don't want that type of piping to exist. We removed the lagging. There's some others that are actually worse than that. We were going to have some of it RT, radiography on it for NDT purposes, non-destructive testing. Sorry if I'm using too many acronyms. When they removed the lagging or the insulation off the pipe, they were afraid to touch the pipe. It was in such bad shape. So we've got about a $5 million a year commitment right now in the budget for the next 5 years to take care of some of this. We're doing additional engineering evaluations of other systems out there, and so that number may actually increase a little bit depending on what we find. We're currently finishing up one at MSRE. In addition, we're continuing to execute our groundwater mission. We've got a 30-year commitment on the reservation to look at groundwater. We've got active pump and treat systems at all 3 sites ongoing right now. We're on site collecting data and performing analysis. We're currently finishing an off-site groundwater project. We've sampled a little over 40 locations. At least the department's opinion is our preliminary review shows that we don't think there's any off-site groundwater or drinking water exceedances from DOE operations. But we are continuing to work with the state and EPA to define what the future programs will be and research will be on that project. And so the message here, at least for me, is we think we have a comprehensive program for the cleanup here. That's IFDP, which in fact I'll be in DC briefing on Monday to NNSA and Science. We have congressional support right now that's been very generous for our programs, and they fit in with our program priorities. And we have partnerships, we feel, with key stakeholders, such as this board, our regulators, to continue to make good progress here in Oakridge. And that's the end of the presentation. I'll take any questions now, or do I wait?
Okay, I want to remind people, if you want to ask a question, please turn your name tent up like this, and I will go around the room.
Okay, Ed?
Yeah, I got a couple of things. What would happen to the whole road after 2020?
Well, it depends. The whole road, the portion that goes from ETTP over to Y12, we're actually looking for a partner to take over if they want it. So for instance, Y12 will be storing material for UPF out at 1065, K1065. If they want the whole road to transport that material over, we would certainly be willing to discuss that with them. If the state or Croat or somebody like that, or one of the businesses wants it, but ultimately EM doesn't need the whole road, so our ultimate disposition, if you find no other takers for it, would be that portion of the whole road we would essentially abandon. I'm sure we would have to do some grading and restoration, but we would stop using and maintaining the whole road.
All right. In terms of the budget, so if we go with the best case scenario, an average between the Senate and Congress, does that mean that if you take the average, you're going to be about $40 to $50 million short, more than likely, than 2016?
No, I don't think we will. In 2016, we got about $100 million plus up. So the president's budget in 2016 was in the 360 range. So we actually ended up in 16 with about 100 million. I think it was 108 million above the president's budget, if I remember right off the top of my head. So the president's budget actually is more in 2017 than it was in 2016. And so either the House or Senate mark makes us okay for our program priorities. Obviously, the Senate mark is much more generous, and a lot of that is in excess facility efforts. But even the president's budget, I think, contains about 10 million to focus on excess facilities. So does that answer your question?
Yeah, it does.
Okay.
Then in terms of the excess facilities, the D&D, is it going to go beyond 2024, you think?
The D&D at Y12 and RNL will just start in 24. The D&D at ETTP will finish up by 2020.
2020.
And so there'll be groundwater, there'll be some post-closure activities, but the plan is to try to have ETTP closed sometime between 20 and 24 and have that workforce moved over to Y12 to start D&D and restoration activities over there in earnest by 2024.
Jay, do you think the D&D part of the excess facilities, it'd be more difficult, more expensive?
I don't know that it'll be more difficult or expensive. One of the things that has had us concerned that we've been talking to UCOR about, and of course, UCOR really can't do that work, right? UCOR's contract is really a closure contract for ETTP with some work at Y12 and RNL. So when we go in earnest to D&D at Y12, we'll have to have gone through a new procurement and have a new contractor on board.
I see. Okay.
So we're looking at 18, 19 standing up an IPT. But one of the things we've been talking to them about is, the facilities at ETTP have generally been very similar facilities. The gaseous diffusion plants have different generations, different size equipment, but essentially the same hazards within the buildings. So you get fairly, you get some experience in K33, for instance, which is where it really started, and you just carry that forward as you went through the gaseous diffusion buildings. As you went back in time, there were some different materials. There were different materials that were used in K25, for instance, in the mid-40s than there were in K31 or K33 that I think was built in the mid-50s. 56 or 59 sticks in my head. So there was a difference in some of the materials, both of construction, some of the materials that were actually used in the operations. But by and large, the hazards were similar. As we move over to Y12, it's going to be different hazards, right? So in different types of buildings. And so that has a big concern. We've been talking to the contractor about that you really need to be aware that you are not complacent when you get into these buildings because of the different types of hazards that are there. Different materials were used for processing over there.
But in the process, Jay, lessons learned will start playing a big role, I guess, huh?
Well, you'll have lessons learned from how to approach things, right? You keep the building shell intact. You don't let the roofs get in bad shape because once the building shell starts degrading, it's hard to put people in there because it's not the nuclear risk. It's not the material going critical. It's stuff falling on people, people falling through floors. You don't have good structural components anymore. You're not sure about electrical systems and how to lock out, tag out those systems because over 40 years, you don't know where things went. You've let rainwater get into it. You don't have good grounds anymore. So those types of lessons learned will be directly transportable.
Good.
So,
Thank you, Jay.
any other? Yes, sir.
I'm going back to your surveillance and maintenance program. With regard to that, are concerns that the team finds that they brought forward to the FFA parties to reevaluate priorities?
I'm sure they will be if there are major issues found within the buildings that would affect the FFA. So I don't, Dave, I can't imagine off the top of my head anything that would.
Well, we when it comes to how we spend our money, we share all of the data on how we spend our money with the regulators every year, and every year there has been an appreciable portion of it that goes to making sure that our liquid and gaseous and water wastes are all managed well. Those are generally regulated actually by not the oversight office here, but by other components of the state regulatory agency. If it comes to maintaining compliance with laws and avoiding discharges, we don't have negotiational flexibility. We have got to, at a minimum, make sure that our water treatment plants are operating properly and so forth. So we're not going to trade that off in order to do some groundwater pump and treat or soil dig somewhere. If we're talking about something that's discharging to a stream or into the worker's environment, that has to be our highest priority. But I think we do a pretty good job of sharing the budget decisions and making people familiar with the technical challenges that are associated with our surveillance and maintenance program.
I think my concern would be that if you do find something, I know a lot of times your budget is already, as far as what you plan to do, is already there. Mm-hmm. And so something would have to be taken off.
Yeah, that's correct. So if, for example, we have a big challenge, the $5 million we're talking about a year proves not to be enough, we need twice that. It certainly could impact some other commitment we've made to tear a building down or dig up a burial ground. And we would have to go to our partners in the cleanup program and negotiate relaxation of some schedule somewhere.
That's not the plan right now.
Right.
The plan is the $5 million is above and beyond what we had planned over the last few years. So, does that answer?
Yeah.
Okay. All right. Any other questions? Yes, sir.
Yes, there are MSRE and HRE part of the plans for the demolition here at ORNL.
They are. Of course, MSRE, you've got the problem with the salts and how you get the salts out and what you're going to do with the salts. Both of those are further in the future. They're not considered part of the worst that need immediate attention. HRE a little bit, and we are spending some money this year. We thought Colex would not cost us quite as much as it is to remove. We got out there and found some material we weren't expecting, and so we've not been able to do everything in HRE that we wanted to, but there will be money spent on that to remove asbestos, get the water out of the basement that's in there. MSRE, right now we're doing an engineering study. I was briefed on that a couple of weeks ago with some of the other EM staff, DOE staff. We should get that report in at the end of August or end of October 21st timeframe, that will lay out some of the problems they've got out there. And so we can go through and start deciding what needs to get immediate attention, what may take a little bit longer. One of the interesting things, if you know much about MSRE, we have to pump down every so often because you've got reactive gases that come off, and so there's a question about how corrosive those have been on the vessels. And they've recommended we put some type of continuous sparge so you get a continuous sweep with nitrogen through it as opposed to having to go in and pump it down every so often.
The U.S. Department of Energy is cleaning up the Oakridge Reservation of residual hazardous and radioactive contamination left over as a result of decades of nuclear energy research. Much of that work has been influenced by the Oakridge Site-Specific Advisory Board, a citizens panel that provides independent advice and recommendations on DOE's cleanup operations. You're welcome to attend the meetings and be part of this important work. For more information, call us or visit our website.